So in the previous class, Benny, if you remember that what we have discussed, that we discussed about the DH. Okay, why do we need DH? Basically, this DH key, whatever the key DH is, yes, yes, whatever the key DH is generating, it should be exchanged between our two entities, right? Site one, site two. Okay. So basically, before sharing this DH, we have to create what? One secure tunnel, right? We have to create what? One secure tunnel. For that, we require what? How many components? Three components. What were those three components? First one is my yes. First one is my key, which is my pre-shared key. Okay. And other was what was the role of this pre-shared key, Benny? No, 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 no. Look, this pre-shared key is basically used to encrypt our session key. Okay. But in reality, what was it? We have figured it out that it's a public key, which was generated by whom? DP Hellman. We select group now on the basis of that. Okay. So this key is known as pre-shared key. Okay. And this key is configured manually. Okay. This key is configured manually. What was the second thing? Second thing was encryption. Okay, here we have in the encryption, for example, triple dash, AES, dash, all those things. These are the algorithms. Okay, we are going to use this algorithm. So, what is the role of the encryption? It is for the confidentiality. Yes, confidentiality. Okay, and third one was for our hash. In the hash, we will use MD5 SHA anything. Okay, it is for the integrity. Got it? Okay. So today what we are gonna do, we are gonna create the data encryption tunnel. DP Helmets public key will get encrypted in PSK. Not PSK will not get encrypted in DP Helmet. DP Helmet, I've generated one key from the DP Helmet. Okay. Suppose this is my PSK box, the password that I have created. Okay. Then in the tunnel, this tunnel they have secured with two layers. One is encryption and other one is hash. Got it? So first my DP element, that session key, which is my, in reality what that key is, that is my public key. Okay, that gets encrypted in the PSK. Then we have the encryption and hash for the tunnel. Okay, this is how things are working. This, why we are sending this public key? Because on the behalf of this public key, it will get what? Suppose site 1's public key will move to the site 2's public key. Sorry, will move to the site 2. Okay, and site 2 will run one formula. Okay, and on the basis of that formula, it will get what? One secret key. That secret key will be the symmetric key. Okay, which is basically, in reality, this is the key which is used for the data encryption and decryption. In the last class, we have discussed about this thing, na? That how this formula has been calculated. Okay, got an idea that how things are working? Little bit. No. The output that we get from the DP element, na, that is my secret key. That secret key is used for the data encryption and decryption also, because it's a symmetric key. That will be a symmetric key. Although DP Hellman is a asymmetric. DP Hellman is a asymmetric. Why it is asymmetric? Because it is generating two keys. Private key, okay, and on the behalf of private key, it will get, first it will negotiate with two numbers P and suppose G. Uh, let's say any number, okay, whatever the number is. On the behalf of these two numbers and this private key, it will get one public key. Okay, and then other side public key will come to this side, and on the behalf of this public key, this private key and this prime number, it will get what? Secret key, and that secret key will be same on the both sides because of this formula. Okay, so that's why we say Diffie-Hellman is an asymmetric, but the output of that is always symmetric. Okay, and why the output is always symmetric? Because we are using, yes, we are using only one key for the data encryption and decryption. That's the concept of the symmetric key, right? Okay, got it. So now today our task will be to create a data encryption tunnel. Which type of tunnel? Data encryption tunnel. What is the use of this data encryption tunnel, Benny? Yes. So basically here what we are going to do, we are going to create, we can say IPsec LAN to LAN tunnel. Got it? What we are going to do? What we are going to create? IPsec LAN to LAN tunnel. Okay. We can also say it as like a policy based tunnel. Why we gonna say this policy based tunnel? Because here we are defining interesting traffic. Here we are defining interesting traffic with the help of ACS. Okay, and with this ACS we gonna encrypt our data. Okay, basically how we are in reality, how we are gonna encrypt our data? With the help of one protocol, that is my ESP. Okay, so here if we will capture the packet, what we are gonna see? Yes, if I will capture the backshot packet, suppose I have created data tunnel between these two sides. Okay, if I will capture the packet here, what I'm gonna see? I'm gonna see the ESP header, outer header, like this kind of information. In the outer header, we will have what? Public IP. Okay, let me just open the topology. Okay, it will take time. Uh, okay, can you think of a drawback that we are defining interesting traffic with the help of ACL? Can you think of any drawback in that? There is a drawback. Can you think? At the end of the practical, I will tell you what will be the drawback. Nothing. Okay, what happens whenever we create ACL? Do you know the interesting traffic? Suppose here R1 should know. We have talked about one thing, that if we are doing the, just a second, if we are doing the site to site VPN, okay, then this site, it is compulsory that this site should know, this site one should know the information of this site. Okay, that type of thing we call as interesting traffic, right? So site 1 should know the information of site 2's whatever the network it want to advertise. Okay, and same here on the site 2 also. Site 2 should know the information of site 1's network whatever the interesting traffic it has to share. Okay, and there is one more thing. Suppose R1 has network A and R3 has network B. Okay, so I will create a policy on site 1 like this, that source will be A, destination will be B. Okay, so on the site 2 also I have to create same policy like this. Source will be B, it should be A. Okay, it should be vice and versa. If I will say B to C, then C to A, then it will not work like this. Okay, got it? So it should be the vice versa of other side. Okay, can you think of any drawback here? Drawback means any cones? Okay, okay, you're not okay. Got it. Okay, I will give you time. No problem. Let us do the configuration first. Okay, you will have a lot of time to figure out what is going on. So Benny, help me with the configuration. But I have to show you now how I'm gonna tell you. Okay, so help me with the configuration if you are good with the configuration. First, we will start with the assigning the IP addresses on the interfaces. When I look without practical, I can't teach. Okay, 10.1.1.1. So tell me, what I have to do now? What is the first condition while creating the VPN? No, 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 no. First thing is, look, yes. Look, I have to ask you, okay. What is the first condition? First condition is that the public IP should communicate. These public IP should be reachable. Okay. So whenever you start the troubleshooting of the VPN, what is the first thing you will check? That our public IPs are reachable or not. If they are not reachable, then you have to figure out here. Okay, on your ISP side. If your public sites are public IPs are reachable, then what is the issue? Then you have to check for the phase one. Okay, that will be your right now. It will be our ISA camp. Okay, if phase one is up, phase two is down, then you have to check what phase two. So this is how you're gonna start the troubleshooting for the VPN. So this will be the process. First, what is the first process? Public IPs, reachability. Okay, you have to check the reachability of the public IPs. Then phase one. What is there in the phase one? ISA camp. Then we have phase two. What's phase two? It's my IP set. Got it? Now let us start. So we're gonna make this reachable. Look, in the R2 we're gonna do nothing. Okay, you can assume that it is our ISP. So we will just assign IPs here. Okay. So remember one thing. Okay, we will discuss about that part later. So first thing, I'm gonna give a default route here towards ISP. Here let's say the next hop will be 199.1.1.2. Okay, so what is the first thing, Benny, what I have to create now? I've given the default route now. So what is the first thing? We have to start with the phase one. I have to start the configuration with the phase one. So here I have to define what? ISACAM parameters, right? I have to define what? ISACAM parameters. Okay, so how I'm gonna do that? Do you remember the command? ISACAM parameters. When how we can define the ISACAM parameters? Okay. So look. So what we are gonna do? We will start with the crypto ISACAM policy. How? Crypto ISACAM policy. Okay, and we can give any policy name. Then we are going to define all the Haggle parameters. Okay, and here right now in the authentication, right now we will use what? Pre-shared key. Okay, then after that we have to define what? Crypto ISACAM key, whatever the key we want to create, and here we have to define the peer information also. Okay, what will the peer IP for this R1? The peer IP will be this. Okay, so let's start with the configuration. Crypto, sorry, crypto ISACAM policy, let's say 10. Okay, hash MD5 authentication, pre-shared key, encryption, triple dash, and what's remaining? Group, let's say 2. Okay, crypto ISACAM. Now I have to define, I have shared here, tell them that authentication we're going to use the pre-share, so I have to define one key. Crypto ISACAM key, Cisco. Okay, what is the peer Benny for R1 for the site 1? 200.1.1.1. Okay, I think command has been already saved. Okay, so let us discuss further. So after completing the phase 1, what is the next step, Benny? I have defined the ISACAM parameters. What is the next step? Yes, pre-shared key has been defined. Okay, that also comes in the phase 1. Okay, after that we have what? Phase 2, right? Here we have to define what? ESP parameters. Okay, so what is the first thing? We have to give the name to the phase 2. But how we going to do that? There is one more, AH, but we generally don't use AH because it doesn't provide you encryption. Okay, that's why we use ESP. Okay, in the IPsec, 90% of the cases, 95% of the cases, you're gonna always see the ESP. Okay, it just, you can just put AH also. Okay, I will show you in the commands. Okay, you can do that, no worries. So after that you have named one thing, that is my transform set. What that transform set is? That transform set is basically a name that we are assigning to our phase 2. Okay, so generally how we assign like T set. Okay, then we define either ESP or we can define the AH, whatever we want to define, and this ESP will integrated with what? Our encryption, whatever the encryption algorithm we want to introduce. Okay, and after that there is a hash and integrity. So ESP, then that will also be integrated into the but we generally we can use anything, MD5, let's say MD5 or SHA, anything you can use. Okay, and here it will also take one more thing, that is HMAC, that will complete the integrity process. Okay, hashing with match. Okay, let me tell you one more thing. Whatever the parameters you want to define on the phase 1 of site 1, or okay, same parameters you have to define on the phase 1 of site 2 also. Okay, if in the H I have taken the MD5, so here also I have to take what? MD5. Got it? But phase 2 can be different. For like in the phase 1 I have taken hash as MD5, so in the phase 2 I can take SHA. Okay, but here on this site 2 also I have to take it what? SHA. Okay, so the combination of phase 1 should be same between same site, between different site 1 and site 2, and phase 2's combination will be, should be same. Okay, on the site 1 and site 2. Got it? Is this much clear? Okay, after the phase 2 what we have to do, Benny? Yes, after phase 2 we have to define the interesting traffic. Yes, we have to define the interesting traffic. Okay, how we define the interesting traffic? Yes, with the help of ACL. Okay. After the ACL, okay, does phase 1 know what's there in the phase 2? Does phase 2 know what's there in the ACL? Or does ACL know what's there in the phase 2? What's there in the phase 1? Are all these three aware about each other right now? If I have defined phase 1 parameters, in the phase 2 I have defined everything, in the ACL I have defined the interesting traffic, are all these three know about each other? Right now, they know nothing about each other, right? Right now, these parameters, my phase 1 parameters, phase 2 parameters, my ACL parameters, does they know about each other? Nothing, na? Okay. So we need what? One component so that I can combine all those three things. Okay. So that component name is crypto map. Got it? You have used the crypto map, right? I think. Okay. So what is the use of the crypto map? So that all above three parameters should know about each other. Okay, how I'm going to do that? I'm going to create, let's say like this, crypto map. Okay, I'm going to create one object, cmap. Okay, we can give it any name, also not name, it's a number. Okay, then we say IPsec should be merged with the ISACAMP. It means our phase 1 phase 2 combine has been combined. Okay, and here in the crypto map we define what? We define match address. Okay, in the match address we define what? Our ACL, whatever the number we have given to the ACL or the name we have given. And here also we will define what? The peer information. What is the peer for the site 1? Benny? Array peer for the site 1. This is my site 1. What is the peer information for the site 1? Site 2 is this interface, right? That is my 200.1.1.1, right? And one more thing, that we have to define the transform set also. Set transform set, what is the phase 2 name? Whatever the name you will give. Set transform set. Then we call that crypto map here in the outgoing interface, from where I am creating the IPsec, crypto LAN to LAN IPsec with the my peer. Got it? We call the like this interface is just like, by this command, crypto map, cmap, IPsec, ISACAMP, with the help of this command. Okay, you haven't done like this. You haven't done configured a VPN like this. Look, there are many methods. Okay. Uh-huh. There are many methods. So let me write down the commands 199.1.1.1. Let me create one loopback. Okay, and we have to define the default route towards my ISP. Let's give it IP 199.1.1.2. So first thing we have to define what? ISACAM parameters, which is my phase 1. Okay, crypto ISACAM what policy, let's say 10, hash MD5, authentication pre-shared key, encryption triple dash, group let's say Q. Okay, so let's see I think it's from 24, right? 24 is the highest. Okay, yes, 24 is the highest. Now we have to define what? Key. crypto ISACAM key, let's say Cisco. Then we have to define the peer address 200.1.1.2. Oh, sorry. Just a second. Just a second. I've done one mistake. 200.1.1.1. Okay. What you were saying? Yes. 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 Basically, you can say that transform set is the name we are giving to our phase two. Okay. So after that, we have to define what phase two parameters. Okay. In the phase two, which protocol we are going to use? We are going to use the ESP. Okay. So crypto IPsec. Here is your transform set. Okay. Let's say T set. With the help of ESP, we are going to merge the triple dash and let's say MD5. Okay. And after that, we have to define what? Interesting traffic. What's there in? It's hash mac. Hash mac. It's a form kind of a integrity. Okay, I think here we will get one password also. HMAC authentication. Let me show you. Hash based message authentication code. It's a part of the integrity. Okay, here I think we define what one more. Yes, we define one password here also with the help of hashing. Suppose the process of hashing, okay, plus our authentication part. It means the password given by me. Okay, it will combine both the things that we call as HMAC. Okay, let me see if I will find any definition here. This is a type of message authentication code that is acquired by executing a cryptographic hash function on the data. Any of now look, integrity and authentication. Okay, generally what I have studied about this, that hash based message authentication code. Okay, it will be like this. I'm not able to find the perfect definition. Okay, but somewhere I read that this HMAC is like a combination of this thing. Whatever the hashing you are performing, and here the authentication. Here in the authentication, whatever the password you will generate. Suppose I generate password as tomato. So it will be the combination of both the things that we call as HMAC. Okay, if I will find a new definition, I have some PDFs, okay, with me. So here on that PDF we have a perfect definition. Okay, I will share it with you. After that, let me open R1 first. So after that, what we have to define? We have to define the interesting traffic. Okay, I'm gonna do with the access list. Okay, okay, access list. Let's give it name one permit. Let's say IP. What's the IP? I want to in the source. Let's take 10.1.1.0. We have to define the subnet mask 0.0.255, and other side network is 10 dot, let's say 2.1.0. Okay, above I have taken for both the sides, this one and this one. Okay, now after this, what we have to define? We have to define one component. Okay, so that all above parameters, all the three parameters should know about each other. Okay, I'm gonna do that. I'm gonna do that with the help of one component that is known as crypto map. I'm gonna create crypto map, and what we say is crypto map entry number. Okay, we're gonna give it number. Let's say 10. Okay, IPsec. There are other methods also. Okay, we will discuss about other methods in later classes. Okay, right now leave it to the IPsec ISACAM. Okay, now we have to define some we can say parameters. Let's say set peer. What's the peer of this? 200.1.1. Set. We have to define phase 2's name. Set transform set. It's C set. And one more thing. What was that thing is? My ACL match address. What's that? The number we have given 101. Okay. Now we have to call this crypto map where in my outgoing interface. The command for that is crypto map CMAP. Okay, the component you have created, CMAP. Okay, so here it is showing ISA camp is on. So if I will show you like this, do show crypto ISA camp SA. Okay, so right now it's not showing anything. I will tell you why. Do show crypto IPsec SA. No packets has been encapsulated. Okay, nothing has been decapsulated. Okay, nothing is there right now. So let us configure the R2. What we have to do into the R2? Just we have to assign the IP addresses. Int E0/0 IP address 199.1.1.2 interface E0/1 IP address 200.1.1.2. Let's try to ping. Okay. Now let us configure R3. Enable confi interface E0/0 IP address 200.1.1.1 200.1.1. Okay. Then if I will try to ping from R3 to R1, will it ping? Yes. Yes. In R2 we have just assigned the IPs. Yes. Will it ping? No, na. Why? Because in R3 we haven't given the default route towards ISP right now. Okay. So we have to give the default route. I know everyone forgets to give the default route. Everyone is just focused about the configuration of the IP. We have to create phase 1, we have to create phase 2. They forgot basic thing, communication between the public IPs. For that you have to define what? A default route towards ISP. Okay, 200.1.1. Now will it be able to ping? Yes. Now same thing, Benny, help me with the commands please. Yes, help me with the commands. I'm saying on R3 what I have to configure now. I've given the default route, I've assigned the IP addresses, I have created one loopback. Now, yes, yes, yes. Crypto, we have, look, I don't want commands like this. I want like this. We have to define the phase one ISACAM parameters. Okay, you can just say this thing. Okay, crypto ISACAM, yes, crypto ISACAM policy, let's say policy number 10. Okay, and authentication, pre-share key encryption, triple dash, hash, MD5, anything remaining group. We have taken group there too. Okay, remember, if I will take uh, wrong group number here, what will happen? Yes, phase one negotiation will fail. I have told you na how we troubleshoot the our VPN tunnel. First, we check the public IPs, are they reachable or not with each other. Then we see the phase one. Okay, if whatever will happen in the phase one, basically we have given wrong parameters. Okay, or maybe the PSK is wrong. Okay, these are the things that happen generally. Okay, now if you will talk about phase 2, what will happen? Same thing, wrong parameters. Or if in the phase 1 there is one more thing, that the ACL part, or we can say in the phase 2, that comes under the phase 2 part. Okay, the ACL part, you have given the wrong ACL. Okay, any IP, maybe you have put the IP host. Okay, in the instead of taking the whole network, you have taken the host, and you have taken wrong host or wrong network, whatever the thing is. Okay, and one more thing, generally one more thing that happens, that you have taken the wrong peer IP addresses. Okay, suppose here you have assigned the IP as 200.1.1.200.1.1.2. Okay, and here in the site one you have taken the peer IP as 200.1.1.1. Got it? These are the general things that happened in the kind of errors we see on the VPN. Okay. Now after this, we have to define the key, crypto, ISACAM, key, Cisco, address. What will the address be? Any peer address? Got it? Now we have to define what? Our phase two parameters: crypto IP set, transform set, T set, ESP, triple dash ESP. What we have taken there? MD5, HMAC. Okay. After that, what we have to define? The ACL, right? Crypto, sorry. Access list, we can give any name. Permit, IP, host. I look. IKE has two versions. Okay, that will come. I will tell you about these things. Okay, be patient. After DM VPN, we're gonna discuss about this thing. Right now, just think that IKE is your ISA camp. Okay, IKE version 1 is your ISA camp. Okay, mainly we have to focus on what? IKE version 2. That will come up after DM VPN. Okay, here I will introduce you the, sorry. No. You can say that IKV1 is same kind of ISACAM. Okay. IKV1 and IKE. Sorry, IKV1 and ISACAM are same. Is this much clear? For now. Forget there is IKV2. Okay. Yes, they both use same UDP port number 500. Okay. Let me just show you IKEV1 port number. Okay. Look, we have to go in a series wise. Otherwise, we have to skip many topics. We have to skip SVTI, GRE. Yes, yes, it is not relevant. Yes, I have to tell you. I have to tell you. I have told you na when IKV to come after the DM VPN. When we will complete the phase one, phase two, phase three. Okay. Huh. Yes. Yes. No problem, no problem. Okay. So we will go like this. You right now for now you can see that we are continuing IKV1. Okay, in the phase one whatever we are considering, that is my IKV1. Okay, there are differences between IKV1 and IKV2, so I can only tell you in a separate session. I have to take one separate lecture for that. Okay, that part will come after the DM VPN. Okay, just a second, I think my debit card has come. Okay, I'm getting call from home. Just a second. Yes, Benny. Okay, so where were we? Look, there are many things that we are that we have to cover little by little. Okay, for example, I will not discuss right now transport mode, tunnel mode. Okay, we have to discuss it. I think after SVTI. No, before SVTI. After GRE or IPsec, I will discuss transport tunnel. Okay, so every trainer has their own way to teach. Okay, generally they define everything here. So I generally define where it should be implemented. Okay, where transport mode should be implemented. Okay, then I will define you that part. Okay, rather than the telling you the theoretical part, I have to show you that practical part. What is the requirement for the transport mode? What is the requirement for the SPTI? What is the requirement for the IKEv2? Okay, so we'll go on a series wise. Just you have to just for that thing you have to just be patient with me. Okay, so here you can see that there I have defined what with the help of network. Oh, okay, I haven't used the host command. So here what we have to do, we have to use it like same. Okay, there in the source I have what I have taken. What is the network I have taken, Benny? 10.1.1.0. Here I have to take 10.2. The destination that we have taken there 10.2.1.0. Okay, 0.0.255 boring lecture 10.1.1.0 0.0.255. Okay, now what we have to define, we have to define the crypto map CMAP set peer 199.1.1.1 set transform set T set match address. What is the address? 101 interface E0/0. Let's say crypto map CMAP. Got it? So let me show you. So right now we have configured our tunnel on both the sides. Sorry, our phase 1, phase 2 on both the sides. Let me capture any one side's interface E0/0. Look, Benny, you have to do now practicals. Okay, I'm not talking about learning the commands. Practical and capturing these packets. It will be a great help. Okay, and just focus on the size. Okay, from the GRE I will introduce you the size. Okay, right now it's what's the size? 60 bytes. Okay, oh forget it. This is a different size. Leave it. We haven't I haven't shoot any IPsec packets, right? Any ESP packets I haven't done. Okay, I was showing you the MAC address. What's that? I think the CDP protocol packet size I was showing you. Okay, that's not our part. So I will show you. So right now, if I will write the command do show crypto IPsec as say. Okay. So here we can see nothing is there. No packets has been encapsulated. Do show crypto. So if I have to watch the phase 1 information, how I'm going to do that? ISACAM SA. So right now, can we see anything here? Nothing, na? Let me just check. Okay, so from here there are commands. You can just do the question mark. It will show you the profile. Okay, right now it's not showing. SA also it's not showing. So mainly from the SA you will see. Is there a detail part? Default policy. I think these are the algorithms that we have defined. Okay, no. These are the default part. Okay, so we can implement the ISACAM as a default also. Okay, like for example, right now what we have given the Haggle parameters, right? By ourselves. Manually we have done that, na? Remember, in the phase 1, we have defined everything manually. Hash, authentication group, okay? But here, they have a default feature also. Okay, that's the feature I will also show you in someday. Leave it for right now. So right now, we can see that my phase 1 is not up. Okay, so remember this thing, that your phase 1 will not come up until your interesting traffic will get hit. Okay, so I have to do what? I have to ping to, I'm in which router? R3. Okay, on the side 2. So I have to ping my interesting traffic 10.1.1.1 from the source. What will be the source? 10 dot LAN network, na, right? 10.2 dot 1.1. Uh, IP address not known as the interface. Okay, on the R3 we haven't configured to show IP in VR. Okay, no loopback has been created there. IP address 10.2.1.1, 255.255.255.0. Okay, leave it. So let us try to ping. It is pinging. Let us see the packets. Okay, main mode, quick mode, leave it right now. Okay, I will tell you about all these packets in later after the DM VPN when the IKV1 start, IKV2 start. Okay, there we are gonna discuss about these things. Right now, just focus here that the ESP packets. Okay, what is the size? 166 bytes. Okay, here look here you cannot see anything. Why, Benny? This is the nature of the ESP, right? So whatever the payload you will have. Okay, okay. ESP is a basically a protocol that will encapsulate everything. It will encapsulate everything. So how a generally packet flows? ICMP, you will have a ICMP payload. When you are pinging, you will have a ICMP payload. When you are doing routing, you have a EIGRP or whatever protocol you are using, right? Then you will have what? Your inner header information. In the inner header, in the source IP, what we will have here? 10.2.1.1, and the destination IP, what we will have? 10.1. You can just say the loopback. Okay, I should know that you get the idea that what I am talking about. In the inner header, you got it na? Got it na? Then what we will have? We have the ESP header, right? ESP header. Then we will have what? Outer header. In the outer header, what's that? Yes, yes. Whatever come here, this thing it will encapsulate everything. It will encapsulate this part. Okay, this part will remain. This is my outer header. Okay, so in the outer header, what will be the source IP and what will be the destination IP? Let me show you the figure. Let me show you the topology. Tell me now, what will be the source IP and what will be the destination IP on the outer header? I ping from the R3 to R1. On the outer header, I am talking about. Yes, our public interfaces IP. Okay, that is 200.1.1.1, and here the destination it will be 199.1.1.1. Okay, in reality, na, on the behalf of this header, routing performs. It will check the routing table. Okay, it will check the routing information on the behalf of this addresses. Okay, it will come in the later classes. Okay, the role of the outer header. Okay, but right now I will showing you just this part, that this much thing has been encapsulated. Who encapsulated this part? The ESP. That is the role of the IPsec na, to secure our data so that no one can see, right? This is the nature of the ESP protocol. What is the role of the IPsec? Data security, right? Data encryption, we can say. And who performs that part? IPsec uses which protocol? ESP. Okay, so the ESP header will get add. Okay, so whatever the information will be here, it will get encapsulated. Okay, is this much clear? So here in the Wireshark, we can see one thing, that is, if I will open it, so here you can see only the public IPs, right? You can only see the public IPs. Anything else can you see? Let me show you. If I will ping one more time, we will not be able to see any uh, we will not be able to see any. Can we see that which services we are which service is applying here? Is it EIGRP, FTP, DHCP, Telnet, ICMP? Can we see anything here other than this source IP and destination IP information? We cannot see anything, na? So that is the role of the ESP. So that our data should be encapsulated. Okay, that is the working of the ESP. But you will say, if we have this ESP, okay, if we have this ESP, then why do we need GRE? Now the main part has been come. If, did you get my point? If we have this ESP, okay, and it is securing our data, our main motive is that in the ISP side, no one can see what type of data has been traveling, right? Which services I am using, and in the internal which networks are running. Okay, this was our task, and with the help of ESP we are achieving this. Then why do we need GRE? At the starting of the classes, I have asked you one thing, that we are creating the interesting traffic with the help of ACL. Then what will be the issue? What will be the issue? So the drawback is, whenever I will add any new network now, what I have to do? I have to create ACLs manually, right? So if I suppose this network goes down, okay, we are not running this network. Suppose we have hundreds of network on this side, okay. Suppose for next 1 month I have to shut down 20 networks, okay, and I have to introduce 30 more new networks. Then what will happen? It will be a burden for the administrator, right? You have to create manually everything. First thing is that ACL we have to create manually, interesting traffic, right? And second most important thing is that can I use the dynamic protocol here? Can I use dynamic protocol here? On my site 1 and let me just remove it. On my site 1 and site 2. Why? Before that, answer me this thing. Does IPsec support multicast? Is it IPsec is multicast or unicast? Yes. By nature it is unicast, but it supports multicast also. Okay, that we are gonna see in the later classes. Okay, but right now we will assume that it supports unicast. Okay, the nature of IPsec is unicast. So if this interfaces will not become the member of the multicast group, will they ever be able to communicate between the dynamic protocols like OSPF, EHRP? For the EHRP, this interface should become the member of 224.0.0.10. Okay, one thing is this, and one thing is that they should be point to point. Okay, to create the dynamic protocol, it should be point to point, right? Our ISP will not entertain the private networks. ISP never entertain the information of the your private networks, right? It will not store this information in internal network in the ISP, okay, in its device, right? It just works on the public network, okay. So they are not point to point. R1 is not point to point with the R3. R1 is not directly connected with R3, right? So we have to make it directly connected, we have to make it point to point. So what's the concept will come? The concept of GRE will come. What happens in GRE? In GRE we create one tunnel, which is kind of our virtual interface. Got it? So they are virtually connected. So in reality here we have started the concept of tunnel. Okay. So this thing we are going to discuss in tomorrow's session. Okay. Ho ho.